Hi, and welcome to the flipped recording for 2.04 Atomic and Mass Numbers. So just a reminder, please don't forget to complete your science notebook slide each time you work on a lesson. Those are submitted at the end of the unit as the Part 2 test. For each slide, you need notes on the left and guiding questions on the right from each lesson in the unit. And there are templates that are already formatted with the lesson names, the guiding questions and all of that in a PowerPoint file found under content in the course. You do want to complete a slide each time you complete a lesson, so you are not trying to do it all at the end. So if you struggle with note taking, watching these recordings is very helpful. You can listen to the parts of the lesson that I tell you to add to your notes. I will also be covering the guiding questions, so be sure to jot down those answers as well. For this lesson, we have 8 guiding questions that we'll be covering. Remember, those are found in order as you read. So as we get started, the first question we're looking for is where are protons, neutrons, and electrons located in an atom? And I usually take a little screenshot of these, and I open up a Word document over on the side. That way, as I'm going through, I have a copy of the questions that we need to be looking for the answers to, so you can do something like that as well to make sure you're answering all those questions as you go. So as we get started, we're looking at the history of the atomic model. It is important, there's a lot of chronological information here. It talks about how the model was developed, so it is important to have that in your notes. So John Dalton proposed that all matter is made of small particles called atoms. He also believed that all atoms of an element are the same. However, this is not quite correct. It is true that all atoms of an element behave the same way in chemical reactions. This accounts for most everyday observations of the behavior of elements. In this lesson, you will learn how atoms of the same element can be different. So again, we've got our goals. We are wanting to understand and define atomic number. We want to compare the atomic number with the atomic mass. So if you look at the periodic table, you're looking at the number in the top left corner versus the mass, which is the decimal under the element name. And then you're wanting to be able to explain how an isotope of an element has the same number of protons, but a different number of neutrons in the nucleus. And we're also going to explain that isotopes of an element typically have many similar characteristics. So the first thing I would put in your notes is the definition of isotope. It's important to understand what this word means. So remember, it's one of 2 or more atoms of the same element that have the same number of protons but a different number of neutrons. And I would underline the words different number of neutrons. That's the most important thing to remember when you're talking about an isotope. So as we jump into the lesson again, here's the guiding questions. The first one we're looking for are where are protons, neutrons, and electrons located in an atom? And this is a review. If you watched the recording or if you remember from 2.03, we covered where those were. So that will be a really quick and easy question to answer. But it will pop up at the beginning of the lesson. All right, and my screen's loading really slowly. So here we go, talking about the structure of an atom. Most of an atom's mass is located in its nucleus, where positively charged protons reside with neutrons possessing no charge. Circling around the outside the nucleus are negatively charged electrons. In an electrically neutral atom, there are an equal number of protons and electrons. So this does answer guiding question number 1. The protons and neutrons are in the nucleus, and the electrons orbit outside the nucleus. Another important thing to note is they're always going to be the same number of protons and electrons in an atom. So it says study this atomic model and answer the following questions. So we're looking over here. We've got protons and neutrons here and electrons orbiting. So which subatomic particle is shown in yellow? And we know those are the electrons. And identify the electrical charge of each type of subatomic particle. So if you remember, protons are a +1 or positive, electrons are a -1 or negative, and neutrons possess no charge. So this would be a really important thing to have in your notes. Maybe you want to take a screenshot and add that along with this image. That would be great in your notes. So determining protons of atoms. All atoms of the same element possess the same number of protons in the nucleus. This number, which is different for each element, is called the atomic number. Think of it as an element's personal identification number. So if you remember back to your periodic table, the number in the top left-hand corner, the atomic number is also the number of protons. So for example, the atomic number of the element aluminum, Al, is 13. This is different than the atomic number of copper, Cu, which is 29. The identities of these two elements are different due to the proton numbers in their nuclei. So what is the atomic number for oxygen? So if you find oxygen, it is 8. And how many protons does an atom of lead possess? So you just look up the atomic number. So it's element number 82. That means it has 82 protons. And that also means, don't forget, that it has 82 electrons. So important things to look at here. This is showing a lithium atom. It's got 3 protons. It's got 4 neutrons. And it's got 3 electrons in blue. So beryllium, Be, has 4 protons in red, 5 neutrons in yellow, and 4 electrons. So you're seeing that protons and electrons, that number always matches up. And then finally, we're looking at oxygen. Oxygen with the symbol O has 8 protons, 8 neutrons, and 8 electrons. So moving on, determining the electrons of an atom. While the protons give an element its true identity, the electrons give an element its personality. An element's chemical properties are determined by the number and arrangement of its electrons. So that is an important sentence. I would put that in your notes. Electrons are responsible for forming chemical bonds with other atoms during chemical reactions. That's an even more important sentence. So definitely want that in your notes as well. An atom is electrically neutral, meaning it contains an equal number of protons and electrons. Thus, by knowing the atomic number, the number of protons, you also know the number of electrons in an atom. You could summarize this, but this is a great thing to have in your notes as well. Changes in the amount or bonding of electrons affects the neutral nature of an atom. Atoms losing electrons become positively charged ions. That's because they have more protons than electrons, while gaining electrons make the atoms negatively charged. So how many electrons are in the atom of sulfur? So sulfur is element number 16. It's got 16 protons and 16 electrons. And then how many electrons are in the atom bromine? Bromine has 35 electrons. All right, so taking a look back over at our guiding questions, what does the atomic number tell you about the atom? That's number 2. And so we know the atomic number tells us how many protons it has. And then question number 3 says, how do you know how many electrons an atom has? And we just read that. It's the same number of protons. And then question number 4 we're looking at is talking about the atomic mass and how it's measured. So as we go on, here is the atomic mass. The sum of the protons and neutrons is described by the atomic mass, which is a measure of the average mass of all atoms representing an element. And it is indicated by the unit AMU, or atomic mass unit. So that answers question number 4. I would also include that definition in your notes. The atomic mass is the measure of the average mass of all the atoms representing an element. And then I would also put measured by AMU's atomic mass unit. And then by knowing the atomic number and the atomic mass of an atom, you know how many protons and neutrons are in its nucleus. So if we look at this, it kind of gives you a cheat sheet for understanding, maybe a quick guide to counting protons and neutrons. And I would definitely include this in your notes. When you look at the periodic table, you're given the atomic number, we've talked about it, and the atomic mass is the decimal number that's right below the element name. So if you want to find the number of protons, that's just equal to the atomic number. If you're looking for the number of neutrons, you're going to subtract the mass from the atomic number. So if we look at this information, it says explore the periodic table to view a list of elements with the first 10 atomic numbers. Notice that most of the atomic masses are close to whole numbers. This is because these elements have one isotope, and they're a lot more plentiful than the others. When the atomic mass is not a whole number, it's because the element has several other naturally occurring isotopes. So that might be something to include in your notes in understanding isotopes, is if it is not a whole number, if it's a decimal, there are other isotopes of the element. So a good idea is to print out the periodic table and have it handy as a resource that you can frequently refer to throughout this lesson and unit. So I always encourage you to keep a periodic table. ptable.com has a great colored printout that is really good. It has the elements' names, symbols, and all of that information. So if we look here, you've got hydrogen, it's symbol H, 1 proton. It does not have an isotope. The atomic number is 1. The atomic mass is 1.8. So if you're looking to find the number of neutrons, you can round this number and you're able to subtract those to get the number of neutrons. Okay, so the atomic mass minus the atomic number. So you can see that all the way down. And then here is also a link to a document that you could print out as well. So here's a little practice game that I encourage you to go through. You're using the equations that we just learned and a periodic table to determine the identity of some common elements. You'll also practice finding the number of protons, neutrons, the atomic numbers, and masses for some elements. So don't skip over these activities. These are things that you will see on quizzes and tests and will need to know how to do it. So which element has 15 protons and 16 neutrons? All you would have to do is grab your periodic table and look up element number 16, which is, I'm grabbing my periodic table. It is sulfur. And from there, you're able to answer the question. Did I do that right? 15? Or did I look up 16? It's phosphorus. Sorry. Phosphorus. So check. And you can go through and practice, and this will help you get more familiar not only with the periodic table, but being able to answer all these types of questions. So don't skip that. So now we're going to talk about isotopes. So let's check back with our guiding questions and make sure that we're caught up. We talked about the atomic mass and how it is measured, AMUs. Number 5, what are isotopes and how are they named? So that's what we're looking at now. While atoms of the same element have the same numbers of protons, they can have different numbers of neutrons. These atoms are called isotopes. So that is the answer to the first part of question number 5. And it says neutrons don't get involved in chemical reactions, so their presence does not affect the chemical property of an element. Here you can see the nucleus of a carbon atom with 6 protons and 8 neutrons. And you also see the nucleus of a carbon atom with 6 neutrons and 6 protons. These are 2 different isotopes of carbon. An isotope is named by adding together the number of protons and neutrons. That is the answer to number 5. How are they named? So you could add that to your notes, or since it's an answer to a guiding question, just answer it there. So they're named by adding together the protons and neutrons. So carbon-12 contains 6 protons and 6 neutrons. And then if you look down, it says carbon-14 has 6 protons and 8 neutrons. So how many protons and neutrons does the isotope lead-208 possess? So if you look at lead, you can find the atomic number. It's got 126 neutrons. So all you would have to do is find the number of protons, look at 208, and do some subtraction to get this 126 to figure out how many neutrons it has. And then the next question, how many protons and neutrons does the isotope uranium-235 have? So all you would have to do is look up uranium on the periodic table. It's got 92 protons. So you would subtract 235 minus 92. It gives you 143 neutrons. So writing down how to figure that out might help you if you need to include that in your notes. Question 6 says an element is a combination of what? And so we're looking to see if that pops up in this reading. So many people think isotopes are a special kind of atom or material different from normal materials and probably something to steer clear of. This is probably because they have often heard the term radioactive isotopes. In truth, all atoms are isotopes. When a material is referred to as an isotope, it means that all the atoms of that isotope have the same number of neutrons. When a material is referred to as an element, it means that all atoms have the same number of protons. So this would be something good to put in your notes, is understanding the difference of something being called an isotope. I would put isotope equals same number of neutrons. Element equals same number of protons. Put that in your notes, and then you'll be able to distinguish between the two. And then an element is the combination of all the different isotopes that exist for the element. So that might be something to include as well. So an element is a combination of what? And that is guiding question 6, and it said it's a combination of all the different isotopes that exist for the element. So that answers guiding question 6. We only have 2 more. So the next one is how are isotopes written? So here's the answer. Isotopes are written by using the name of the element followed by a dash and a number. So you could write an example of what that looks like. This number is the sum of the protons and neutrons in each atom. It is the isotopic atomic number, which is specific to the isotope. So you can see what it looks like here. The sum of the protons and neutrons, right? You've got the name of the element followed by a dash and a number. Okay, and that looks a little bit different here. This is like the number with the symbol. So going on, for example, the element 10 possesses numerous isotopes. One of these is 10-112. So that's how they're written. And the atomic number, or the number of protons of 10, is 50. However, this specific isotope of 10 contains 62 neutrons, and that is different than 10-114, which has 64 neutrons. So every time we're seeing 10 is the symbol SN, which can be confusing, but all of the protons, 10 is always going to have 50 protons. That can never change. But the number of neutrons is what is going to be different. Okay, and so that's how you're getting this 112, 114, 115, and you can see it's the number of neutrons that are changing each time. So most elements have several isotopes. Review the list of naturally occurring isotopes of 10. Naturally occurring isotopes are those found in nature. And note that there are also isotopes that are man-made. And if we click here more on isotopes, there are 10 naturally occurring isotopes of 10. 10 the number, and then 10 the element. Naturally occurring means they are found on Earth, even if in small quantities. Scientists, however, have created another 8 isotopes of tin in laboratories, and all of those isotopes are radioactive. All right, so we've answered question number 7, how they're written, just like this, the name, dash, and the number. Question number 8, you might put that in as an example as well. And then question 8 says, what is the difference between stable and unstable isotopes? So let's keep looking. This looks like a little activity. So like the electrons that swirl around the nucleus of an atom, some of the numbers and calculations pertaining to an element's atomic number, atomic mass, and the number of subatomic particles may still be swirling around in your head. See if this review can help you just sum things up. So it says drag the words to complete the paragraph. So here they are. All atoms of an element with have the same number of, if you remember, it's the same number of protons. But within the same element, there may exist atoms that have blank numbers of blank. So different numbers of neutrons. Atoms that have the same number of protons but different number of neutrons are called isotopes. The neutrons are located in the nucleus along with protons. Isotopes can occur naturally or they can be man-made. All atoms are isotopes. Isotopes are written using the name of the element followed by a dash and the sum of the protons and neutrons. So if you check that, we got them all correct. And you may want to take a screenshot of this and put it in your notes as well. So it's a numbers game. Here's an activity for you again. Atomic numbers of elements can always be found on the periodic table. However, it's important to remember that the atomic mass of an element shown on the periodic table represents the average of the masses of all isotopes for that element. If you need the number of neutrons in a specific isotope of an element, the name of the isotope contains the specific isotopic atomic mass in it. So it is important to use this mass in your calculations for neutrons of the isotope. Try this example. So it says compare the number of protons and neutrons for both the general element uranium and for a specific isotope of this element, uranium-235. And we did that a while ago on the chart. So we saw the number of protons for uranium, and that never changed, and then the neutrons did. So just an example of that again. And if you look at it again, uranium-235, they both have 92 protons, but uranium here says it's got 146 neutrons, whereas uranium-235 has 143. So that is how you're looking at that isotopic mass. So based on this table, it just talks about what we went through. For the element uranium, the average atomic mass shown on the periodic table, you subtract the atomic number. So if you have 238 minus 92, that gives you 146 neutrons. So again, it's just talking you through how you calculate that and giving you some more practice problems. There are 10 that you can check. So again, these are important to do to understand how you calculate these. Put an example in your notes and make sure you don't skip over that part. And then we're still looking for that last guiding question on stable and unstable isotopes. But before that, we've got, it says use the objects in the toolbar to build atoms. Reference the periodic table as needed. The circle with the positive circle is a proton, the plane is a neutron, and the circle with a negative symbol represents an electron. So now it says build an atom of helium, and what are some possible isotopes. So you're able to go through and do that. Remember, these are going to go around like this. So this shows you helium-3, helium-4. So just some examples of how to do it and making sure that you can build those. And then finally, here's stable or radioactive. So could you stick any number of neutrons in a nucleus? For example, could carbon-206 contain 6 protons and 200 neutrons? No, this won't work because only certain combinations are stable. A stable isotope of an element is one that does not break apart quickly. So that sentence right there needs to go in your notes and as the answer to number 8, the guiding questions. Most stable isotopes are usually ones that are naturally occurring isotopes of an element. Unstable isotopes may stick around for a while depending on how unstable they are, but eventually they break apart to form smaller, lighter elements. This action is called radioactive decay, and the isotopes that are involved in this action are called radioactive isotopes. So I would include the definition of radioactive decay in your notes and just understand what it is, have that definition, and then also include that those are called radioactive isotopes. So that gives you a definition of unstable as well. And radioactive decay gives off radiation that is dangerous. However, radiation can also be useful. For example, the production of electricity and in certain medical procedures. And then you have here that we use radioactive dating. It's called, basically you can determine the age of rocks and fossils and other ancient objects by using this process called radioactive dating. This process uses radioactive isotopes such as carbon-14 and uranium-238. So here it goes through and gives you some information on how that happens. So this is a really long lesson. There's a lot of information in there. We've answered all 8 of the guiding questions, and now we are at the end to review. So in the lesson review, several things to go over. You may want to include these in your notes if you need some additional information or you didn't get these included the first time. So as we wrap up today, look for our flip follow-up session this week in your Class Connect schedule. Make sure you come see me in Help Lab if you have extra questions or need help, and have a great day.